I'm Robert Gower and I'm studying electronic engineering at the University of Southampton. Today I'm going to talk a little bit about potential dividers and their uses in real-world applications, specifically at the front end of an audio mixer. The circuit itself is actually relatively simple. Audio comes in through the two jacks here. Each goes into its own potential divider, that would here and here. Each of the outputs of these potential dividers then go through some capacitors which filter out any offset from the input, and then into the op-amp circuit, which then amplifies it out and adds the signals out at the output. Okay, so once again, but using the circuit diagram, the voltage goes into each potential divider. The ratio of voltage output to input is set by the equation you already know from A levels. Vout equals Vin times Rb over Ra plus Rb. The signals go through a filtering capacitor to remove any DC offset, and then into the op-amp circuit, which adds the signals. All the signals are generated by a free phone app that's then connected to the board via a 3.5mm audio cable and then a headphone splitter. The oscilloscope is connected up onto the test points on the left-hand side of the board as shown. We'll start off with a simple demonstration to recap what you've already covered at A level, and that is what a potential divider does. So the blue trace just shows the raw signal input at the top of the potential divider, and the yellow trace shows the output of the potential divider. Now we see with no excess light on it, the output is still relatively high compared to the input. But if we shine a light on it, we see that the output shrinks, as we'd expect. Now we'll move on to a more practical example of how two potential dividers can be used to vary the levels of two input signals into the audio mixer circuit. Okay, so now in this experiment we've moved one of the oscilloscope probes so that we can read both the outputs of both the potential dividers. The LDRs are still at the top of the potential divider with the fixed resistor at the bottom as before. Okay, so here we see the blue and yellow traces as our two inputs, and then the purple trace as our output. Now at the moment the two inputs are almost exactly in phase, so they're constructively interfering with each other, and we're getting a large signal at the output. If we alter the phase of the yellow trace, we'll see how they slowly begin to destructively interfere, and we end up with an output of virtually nothing. This setup is the same as the previous experiments, but now we're looking at more how the potential dividers can be used to mix two signals instead of just looking at adding sine waves. So here we see that the yellow trace is a square wave and the blue trace is a sine wave, and there are two inputs. And at the moment they're adding together at the output to form a sort of halfway house between a sine and a square wave. So if we shine a light on the LDR corresponding to the yellow trace, we see that its amplitude reduces drastically, and we're left with a more sinusoidal output because that makes up the larger proportion of the input. And if we do the opposite, that is shine the light on the blue trace, we see that the sine wave decreases and we're left with a much more square wave at the output. But this isn't the only use for potential dividers. The LDR setup we have here is also used in street lighting, so that the lights turn on when it gets dark. Thermistors, which change their resistance based on the temperature, are used in phones to make sure, one, the processor doesn't overheat and the battery doesn't overheat when it's charging. Actual physical twisting and sliding potentiometers are used in real mixing desks because they stay where they are once you've set them. There are many more, for instance more novel ones, such as a tremolo effect or a modulation of the volume of a signal, which is used a lot in guitar effects. So here's a signal going through an actual tremolo pedal, and then here is the same signal with a torch modulating the LDR. And you'll see that it gives a similar effect. So that was potential dividers, and hopefully it's shown you how some very simple physics principles can be turned into some very useful applications in electronics.